everyone. In this video, we're going to talk about binary numbers. So let's go ahead and jump into the material. So first off, why are binary numbers important? Modern computers are digital computers. That is, they store and process information as binary numbers, and that's a 1 or a 0. The CPU, or the central processing unit of the computer, performs all the basic math and computations for the system, and all of these computations utilize binary numbers. The reason why binary numbers are used when computer circuitry was first being built, to come up with circuitry for a 1 or a 0 was way simpler than coming up with something for a 10-digit system, for example. So computers use binary numbers and throughout the systems today. And computers are everywhere in modern society. So if you want to understand the basic operation of a computer, you really should understand binary numbers. So let's go ahead and look at the mathematics behind binary numbers. So binary numbers are represented by 1s and 0s, and it is a base 2 numbering system. Our traditional numbering system is base 10. So if you look at the following number, this binary number, we have 1010. So to convert this number to decimal, you have to do a bit of math. So starting from the right digit, you multiply that digit by the power of 2 in that position, starting at 0, and then add them all together. So let's look at an example of this. We have 1010, and we'll start with the rightmost digit, which is 0. So we'll multiply 0 times 2 to the 0 power, which is 1. Then we'll multiply 1 times 2 to the first, which is 2. Then we'll multiply 0 times 2 to the second, which is 4. And 1 times 2 to the third, which is 8. Now if we multiply those out, we get 0 plus 2 plus 0 plus 8, which equals 10. So 1010 in binary is equal to 10 in decimal. So again, you start from the rightmost digit and work your way over. So this is 2 to the 0 power, 2 to the first, 2 to the second, 2 to the third. And if this would go on out, you would go out in corresponding bits. So that's really how you do the conversion from binary to decimal. And it's a pretty simple conversion, and even if it's a really long number, you just need to make sure that you do your accounting and paperwork correctly to do the conversion. So now let's look at the flip side of that. Okay, now let's look at it from a slightly different aspect. If you look at the table here, we're going to look at the first 10 decimal numbers, and binary numbers are also referred to as bits, and these bits are the lowest level storage on a digital computer. So a bit is either a 1 or a 0, and it's also referred to on and off. So 1 is on, 0 is off. Listed in the table are the first 10 decimal numbers and their equivalents. So let's take a look at this. So decimal 1 is 0001. Decimal 2, or 2 to the first, is 0010. And remember the conversion that we did on the last page. This is 2 to the first, which is 2. So let's go ahead and look at 3, where we're adding in just one more digit. And now, since we're kind of full here, if we go to the next digit, notice how then we have 2 squared, which is 4, and then 0, 0. So you can see the pattern now, how this is beginning to repeat. We'll add 1, then we'll add one more, and then finally when we get to 8, then notice how this shifts. So it's analogous to our decimal numbering system, except for you only have two digits to work with, 0 and 1. And so you can look at this and you can see the pattern here. And let's go ahead and look at some other aspects than of binary numbers as well. So just to kind of wrap up this binary to decimal conversion, we can generalize this process. We can do the conversion by multiplying the value of each digit, n, by d to the nth power for n from 0, the least significant digit, which would be over here, to the most significant digit. So if you look at this following example, then we're going to go through this one more time. We're going to convert 1101 base 2 to decimal. So we're going to start with the least significant digit, over here, which is 1 times 2 to the 0, and then move on over. 0 times 2 to the first times 1 times 2 squared times 1 times 2 to the third, or 2 cubed. And then if you multiply all of those numbers out and do the addition, that's equal to 13. So that's the general case of how you do the conversion. So we first started with a specific example. Then we looked at the table of the first 10 digits of the decimal numbers and their binary equivalents. And now we're looking at the general case of how you do the conversion from binary to decimal. So now let's look at the way you would go from the other way. So we're going to convert from decimal to binary. So this is a mechanical exercise, once again, like the other conversions, but this time, instead of doing a multiplication and addition, you're going to do a division. So what you do is say we're going to convert the number 221 in base 10 to binary. So we put this in this chart up here that I'm outlining. And what we do is we start with the number 221 and we divide that number by 2. If you divide 221 by 2, you get 110, and we write down the remainder in this slot right here. So we'll just keep doing this until we go down to 0. So 110 divided by 2 is 55 with a remainder of 0. 55 divided by 2 is 27 with a remainder of 1. 27 divided by 2 is 13 with a remainder of 1. 13 divided by 2 is 6 with a remainder of 1. 6 divided by 2 is 3 with a remainder of 0. 3 divided by 2 is 1 with a remainder of 1 with a remainder of 1. And 1 divided by 2 is 0 with a remainder of 1. So now what we do is we write those digits down in reverse order to get our binary number. So if we take 1 1 0 1 1 1 0 1 and we write those in reverse order over here, 1 1 0 1 1 1 0 1. So 221 in decimal is equal to 110 11101 in base 2 or binary. So that's how you do the conversion the other way, to convert from decimal to binary. So now you have the tools to convert between both of them. In the next lesson, we're going to have an exercise to go ahead and do that so you can practice that. And that's really it. There's also a way you can do this easier. You can do it online as well. And there's a number of sites that will convert these things. So if I put in a binary value, it'll give the decimal value. So it's best to learn the mechanical way, how to do it by hand first, and then you can use these online tools to either check your work or do more complex problems that would just take too long to convert. But you should understand the theory first before you use the web pages. So this is the binary to decimal converter, and I've put the link in here. And that's really it. So in summary, binary numbers are the basis of how modern computers operate. They are digital computers, and they use ones and zeros for computations. Conversion of these numbers is straightforward. It's just a mechanical process. You have to practice it a few times so that you make sure that you have the method down. And there are also a number of online tools that can do these calculations. So that's really it for this lesson in binary numbers. I hope it's straightened out. If you've ever had any confusion around binary numbers, it's really pretty straightforward, and you really just need to practice the conversion so that you can understand how to do that. That's it for this lesson. Thank you so much, and I'll see you in the next lesson. Bye-bye. Thank you so much for your interest in this video. If you like this video, please click the thumbs up button. If you want to see more videos like this, please consider subscribing to my channel. That's it. Thanks again. I'll see you again soon. Bye-bye.